I'm Conor O'Shea. I work for Daimler Trucks North America, and one of the things that I wanted to talk about today is how we used Neo4j's underlying graph technology to address some of the challenges that we had in separating our business from one entity into two entities back in 2021. So one of the challenges that we had as an organization is the integration between those two divisions in essentially all of our application framework and architecture. So if we're going to separate a large conglomerate that has integrated applications on each side into two separate entities, how do we do so in such a way that we don't end up bringing down one entity or the other when we completely sever that connection? So every business has documentation. Everybody is aware of what happens when you save documentation. How effective is that documentation a month from now, or 2 months from now, or 3 months from now? Nowhere near as effective as it was when it was initially committed, certainly. And when it comes to discovering what an application does, you first have to understand where you were and the things that have happened since that time that brought you to where you are. There are lots of different ways to do this. A traditional way for our business might be to bring in a swarm of contractors to essentially attack the issue and provide us with all of the data that essentially defines where we are now. The problem with that is it takes time, and it's subject to somebody else's interpretation of what an application does. When you bring in a contractor, they're familiar with all of the businesses that they've worked with up until the time that they've come into your business. That doesn't necessarily mean that they understand how your applications work, because their approach to it, their vision of it, is based on their prior experience. So the value of what they're presenting is only useful insofar as you take that into context. In other words, it's not going to be how you view your applications. It's going to be what they discovered about your applications. And you're going to end up with something that is somewhere between a year outdated documentation and where you actually are. But when you make that final cut and you have now two completely separate businesses, you have a challenge. If you've missed anything, say there's an SMTP batch that goes off from a particular application that goes out once a week, and the contractors didn't catch that. That happens to be critical for supply chain. It won't take very long before that supply chain comes to a screeching halt. So I was kind of introduced to Neo4j's technology in 2021. I was looking for a way to present data to our management team so that they could view the relationships between data and what that highlighted for the business. It wasn't this particular use case. It was right before we started the separation process. It was for just some other challenge that we had as a business. And the technology at the time, it did help us identify relationships between things that we didn't think were related. But it wasn't until we really started getting into this process of separation that we really needed to take a look at what is really happening with our applications and how are they related to other applications within our business. And in particular, how are they related to applications with the business that we're going to split off from? That was a big challenge for our organization. And we thought about it and we thought about it. ChatGPT came out, large language models started to proliferate, and we started thinking, can we use this technology along with Neo4j to essentially do what we would have hired those contractors to do? Great idea. We started looking into it, and what I discovered over the years leading up until now is that we didn't know what we didn't know about a lot of things within our organization. Once we finally built that graph, we created an ETL pipeline that essentially takes all of our network traffic, everything that happens within our enterprise architecture. We have a tool called ExtraHop that, if anybody's familiar with that, it's essentially a Wireshark component tied into a tap that you deploy throughout your enterprise architecture, and then it aggregates and pulls those into flow records as opposed to something like just a standard PCAP from a Wireshark capture, which is useful, but something that takes quite a bit more effort to evaluate, and it's tactical, it's not strategic. So that's where we started looking into using large language models to help us identify how can we really surface all of this application information. And that's exactly what we did. That ETL pipeline samples every 5 seconds. It pulls in 2,400 flow records, and it does this consistently every single minute of every single day. Now, this provides us with something that you can't get from contractors, you can't get from internal employees. It provides you a real-time relational view once you transform that into a live graph of your business. Because at the end of the day, it doesn't really matter what your business says that they do to their customers. You can have as many mission statements as you want. You can have as many boardroom meetings as you like. None of that really matters, because what defines a business is what the business does. That's how the public will view you. That's how your customers view you. And that's how you'll be remembered as we move forward temporally with the graph that defines now everything that we do as a business. And what we discovered was enlightening, to say the least. There were applications that were using SMTP to send batches that weren't even associated with documented applications. There were SSH jobs that were essentially running via automated scripts that were kicking off processes that sent backups to servers that were managed by the company that we split from. None of these were documented, none of these were identified, and they were all critical in their own right. So when it came time to complete the separation, which happened earlier this year, all of these one-off cases were identified, categorized, and sent off to the various teams to ensure that no matter what happens, we now have a full view of everything that we need to do before we cut that cord. And when we did cut that cord, any of the issues that we had were not related to our understanding of our architecture, because we now had that understanding. And as we continue to iterate on this, we extended the temporal window from 5 days to 12 days. And using sampling theory, you can take a look at any sufficiently large data set, and if that data set essentially performs the same types of activities all day long. So an SMTP server does what it does. It sends batches of email again and again and again and again all day long. Anybody who's using an automated process, it's going to do the same thing. So it's a perfect fit for sampling theory. And if you take a look at sufficiently large data sets, sampling theory tells us that ultimately, if you can capture 1% of the traffic, you have an architecturally and organizationally relevant model of what you're doing, which then correlates with who you are as a business. If you can get that above 3%, now you have an operationally equivalent model of what you are and what you're doing as a business. We managed to get 6%. And Neo4j's ability to absorb all of those transformations with the Aura product that we purchased has just been phenomenal for us. So we were able to push well past the boundary that creates operational equivalence from a relationship perspective. And now we use this tool every single day, not just for its intended purpose, but I have architects, I have engineers, I have application owners coming to me saying, can we get access to this solution? Because from what we've seen so far, all the documentation that we have in, say, ServiceNow, for example, that represents our application portfolio, the documentation isn't accurate. But with this tool, we can use that as a starting point to map out everything that the applications do. Now, everything that we need can be had simply by going to Neo4j Bloom and dragging and dropping the various nodes and then tracing the path out from there. That's great. That's amazing. That does a lot of amazing things for our business. But there's one challenge. How do I give this to somebody in finance? How do I give this to somebody in HR who says, I had an employee who was working with these systems, they left for whatever reason, we never heard from them again, and now we don't really know what they were doing. So how do I ask about this person, or is there somewhere I can go and just map that out? Now, if I were to give someone who essentially works in HR or finance with no experience with IT access to Neo4j Bloom, it's certainly better than giving them access to the query window and expecting them to know Cypher. But they're still going to become overwhelmed pretty quickly. So to iterate on this technology, what we did is we have an AWS relationship, we have a VPC, and the global business for Daimler Truck AG approved access to the Anthropic Bedrock models from Claude, 3.5 when we first opened it up, now Sonnet 4.5 and Opus 4.1, and now Haiku 4.5. So we have access to all of those components. And what I did was essentially find an MCP first framework, because the critical component in integrating artificial intelligence with any business is not creating a million chatbots or having a document repository and having the chatbots point to it with a simple RAG interface. Sure, you can do that, but that's not going to get your business where it needs to be, and you're not going to really realize the true potential that these technologies bring to the business. So what I did was I deployed an interface that looks like ChatGPT or Claude Desktop or any of those solutions. It's just a chat interface. But now bringing our data, our business data, to the large language model, not just one set, not just two sets, all sets. That's where the real value is. So when you have not just one graph, you have a graph from sales, a graph from marketing, a graph from design, a graph from engineering. And you bring all those pieces together. And now you bring in a graph from service. It has all of our warranty claims. And you put a large language model like Sonnet 4.5 in front of it, and you ask it simply, take a look at all of our recent warranty claims, correlate it with all of these data sets, and tell me why they've increased. Now you have something that's immensely powerful, that can drive your business forward, can highlight relationships that you never would have seen, because again, you don't know what you don't know. In business today, most of my experience has been you have a group that does this, you have a group that does this, there's a group that does that. And they do interact because they have to, but they're not integrated. Interacting and integration are two different things. The integration component is the most important piece, because once you're fully integrated, you understand how everything that your business does relates to everything else that your business does. This is what you would generally refer to as market advantage. The more you know your business, the better your business is going to perform. And that's what this technology allows us to do. Ultimately, at the end of the day, if you don't know what the changes that your design team just made, how those changes impact the product that you're selling or the production process associated with that product, you can estimate what that impact is going to be from a customer perspective. Are the customers going to be interested in this solution? Is it going to encourage them to turn their vehicles in a shorter time frame so that we can roll more product? Or are they essentially going to ignore it? Or are we actually going to force them to move to possibly a competitor because we didn't understand something about the way that they interact with our business? Now you don't need to ask those questions, bring in contractors, and have meeting after meeting after meeting to discuss them. Now you go to DT&A chat, you simply ask it, we've made these changes in the design profile of our latest vehicles. Tell me what you think. Open-ended question. What you think. Correlate that with all of these other data points, all these other graphs that we've deployed. And then present me an executive summary that I can take to our C-level team. That is a real thing. It's happening right now. And all you need to do is essentially create the frameworks that allow these systems to pull that data in from all of those data sources. And moving back to kind of Neo4j and their graph technology directly, when I was asked by a number of different teams, well, why don't you just use SQL? Or, why don't you use MongoDB or something of that nature? There's a very specific reason for that, because when you think about the value of something, what is the epistemological import of a thing? And you start to look at it and you start to think about it, you realize pretty quickly that it's not the thing that matters. It's the relationship that that thing has to other things. That's what defines knowledge. That's where meaning is found. And our business discovered pretty quickly that the way that we'd been doing things before actually hides that meaning underneath relational tables that don't surface anything other than, here's a transaction. Well, great. How do I relate that to literally anything else in our business? And you can bring in a consultant to try and do that. The better way to do that is to take all of that data and turn it into something that surfaces those relations. And that's essentially what Neo4j is. It allows you to take everything that your business is, everything that you do, and surface how that impacts everything that you will be. And that's the most important aspect of prognosticating anything for a business. If you don't know who you are, how can you accurately predict who you're going to be? So that's the power of this technology. That's what it allows us to achieve for our business. Ultimately, there's a lot of different ways that you can approach this. There are lots of different AI tools out there in the market today, and we've looked at many of them. From an agent orchestration perspective, you can look at like Zapier or Make or N8N. But ultimately, what it comes back to is always, you can orchestrate anything that you want. But if you don't understand how the data that you're orchestrating is correlated with the rest of the data that is your business, it isn't going to improve anything. It's just going to add complexity and create a scenario where you essentially buy a product. It has a great selling and marketing team to approach, here's how it will help your business. Here's how you could streamline all these processes. But they're not really addressing the challenge. And the challenge is knowledge, meaning, how do we surface this? And it starts with understanding the relationships between all of the things in your business that you didn't think were related at all. And that's where this technology allows us to really advance everything that we do. We got our first taste of it with using ExtraHop to build a relational graph that represents everything that we are as a business. That helped us separate into two organizations. Originally, it was just Daimler AG. Then it became Daimler Truck and Mercedes-Benz Car. And we did so without any impact to either business. Then the question became, how do we identify firewall challenges? This is a problem that literally every business has. It consumes a significant amount of time, and at the end of the day, we have this siloed mentality where you have the firewall team or the network team, right? Or the hosting team. And you have to get those teams to correlate. But now, since all of our firewall data is sent up into Splunk, we can do the exact same thing that we did with our network data, in that we can take all those logs and turn them into a relational, temporally accurate experience of what's actually happening with all of our firewalls. You can do this with your load balancer data, and which is what we are. We use F5s, and we have the same scenario where we have all of our data up in Splunk, and we've used it to identify where a specific 500 error came in. Say you have a customer who's connecting to your site, and for example, they upload a JSON file of some business process. Somebody else comes in, picks up that role, and they send a JSON file, but the naming convention doesn't conform to the accepted rule on the application's back end. So when they use it, they get a 500 error, but they don't use it every day. It's usually the person who's always done it. Maybe they're on vacation. Maybe they have sick leave, who knows? But this other person comes in and they do it their way, and you get a bunch of 500 errors and it fails. This person likely has some other role in the organization, so they just kind of brush it off and leave a note for the person who usually does it. How do you identify what's causing that problem? If you don't have the ability to visualize what happened yesterday compared to what just happened 5 minutes ago and how they differentiate, there's no way you're going to be able to surface what the actual problem is. You can bring in a team, you can dig into it, certainly, but why do that? Why not just have a graph that shows you everything you need to know, every transaction, and just use your words? We have a problem with a 500 error on this particular F5. Can you just, what is it, and how do I fix it? And at the asking, maybe a minute, 2 minutes later, depending upon how long it takes the MCP server to return all the queries that Claude sent to it, it comes back and it says, oh, here's your issue. The format for the name for the JSON file that's being inserted doesn't match the standard format that's generally being used. So you're getting a 500 error. If you want to fix it, here's how you go to do it. And here's the real trick. So that's great. The next step, the next iteration for this is not, okay, I have to go talk to the application owner. Let's get in there. Let's fix the code. Or we'll just go talk to this person who fills in occasionally and tell them, hey, this is not the right format. You need to use this format. That's okay. But what if the model responded back with, I found the problem. Here's the challenge. Would you like me to go fix it for you? Here's what I think we should do. Give me the go-ahead, and I'll just go make that happen right now. That's the vision. That's the future of software as a whole, not just in our organization, but when we think about how we use large language models today, how I use them for the past maybe 2 years. It was only in the past 3 or 4 months when I kind of switched to a different paradigm. We use large language models to help us build software. Great. But that's not the vision. That's not the future. The future is the large language model is the software. It can reason about itself. It can have discussions about itself. It can respond to you when there's a challenge. It can tell you how to improve software. It can manage that software's life cycle because it literally is the software. And using agent orchestration platforms, you can tie that into everything that you do as a business. And you can integrate that with Microsoft Teams or Slack and essentially run your entire software empire right from your phone with the integration touch point such that anytime there's a new graph that you load up and maybe there's an error that comes back from Neo4j every so often, the model will notify you, tell you how it can be fixed, and you can even set it up in such a way that, let's say the API changes in a new version of, we'll use our case, ExtraHop. And we can now enrich the data that we were pulling out from layer 3 perspective with layer 7 data. The model can proactively go out. Something's changed in the API. Here's a way that we can actually improve the data in the graph that you currently have. And then you don't get a development team together. The model just says, would you like me to do that for you? And then you just say yes or no. And then it runs through maybe a QA or a dev environment that you've given it access to. It tests it out. You take a look at maybe a test graph that you have just to review the changes in the architecture. And if everything aligns, you push it to production, not by redeploying and going to GitHub and doing a git pull and all those things. You just tell the model, I like it, build it. And then you go back to coffee or lunch or whatever you're doing. So that, in my view, is the future of the technology. And Neo4j's graph structure is the foundation that surfaces the knowledge, right? The epistemological truth to the model so that the model can help you drive your business forward in ways that were never possible until now. Thank you, everybody, for your time. I hope you enjoyed the session. Please enjoy the rest of the conference. Thank you again.